Population growth rates are often described as percentages. How do you convert these percentages or growth rates R into growth factors B so that you can construct an exponential growth or decay model? So suppose that the tuition at private four-year colleges and universities is growing at the rate of 6% per year. If the current tuition at Warren Wilson College in North Carolina is $38,400, write a function to model the growth in tuition over time. So my current tuition is $38,400. So let's see, cost as a function of time. My initial value is 38,400. And I am increasing by 6% each year. So I have to pay 100% of what it cost the year before, plus an additional 6%. That's 106% total. So I'm going to multiply by 1.06 every year for 2 years. All right, let's look at this table. I have some exponential functions, and I want to fill in information about that function, and then in other places I'm given information about the function and I want to write a formula. So my function a of t equals 5 times 1.05 to the t. Its initial value is 5. That's the value you get when you plug 0 in for t. So maybe I'll just write that out once. A of 0 is how you calculate an initial value, which is 5 times 1.015 to the 0, but anything to the 0 is 1, so that says 5 times 1, which is just 5. My growth or decay. Is it growth or decay? So it is growth because my factor 1.015 is bigger than 1. The growth factor is 1.015, which means that my growth rate is 1.5%. Right? The 1 means keep 100%, and then the 0.015 is the growth percentage as a decimal. All right, if a of t is 1,000 times 2 to the t, my initial value is 1,000. It's growth because my growth factor is 2, and that's bigger than 1. And my growth or decay rate, take your 2, subtract the 1, and you get a 1, which is 100%. Right? If your salary is doubling every year, then you're getting a 100% raise. A of t is 20 times 0.9 to the t, initial value 20. This is decay because my growth factor is less than 1. Growth factor is 0.9. So that says, if I were to put this in terms of monetary context, $20 is your starting amount. And then at each time period, the amount of money in your account is only 90% of what it was, right? So that means you're losing 10%. Negative 10% is your decay rate. All right, now I'm given some information here. I'm given an initial value and a growth factor. So my formula is going to be a of t equals 500 times 1.003 to the t. And I know this is growth because my factor is bigger than 1. And then my growth rate as a percent, subtract 1 from the factor, and you get 0.003. Change that to a percentage, which is 0.3%. Okay, I have an initial value of 30, a growth factor of 0.84, which actually I should have said that's a decay factor because it's less than 1. So I know this is decay. So that is the amount that I get to keep, right? I start with $30. After 1 year, I multiply that by 0.84. So that's how much is in my account, 84% of 30, which means I lost 16%. So my percent change is negative 16%. All right, I'm starting with $10,000 here. It's growth. My growth rate is 4.05%, which means that my growth factor is 1.045. And then I can write my formula. A of t is 10,000 times 1.045 to the t. All right, let's see. Finally, I have, I'm starting with 200 milliliters of something. It's decaying by 10%, which means that my growth factor is 0.9. So my formula is A of t equals 200 times 0.9 to the t. All right, here's another example of an exponential function. Assume that your kidneys can filter out 25% of a drug in your blood every 4 hours. You take 1,000 milligram dose of the drug, fill in the table showing the amount of drug in your blood as a function of time. So the first two data points are already completed, right? When you took a 1,000 milligram dose at time t equals 0, 4 hours later, you've decreased that amount by 25%. All right, let's pull up my calculator here. So 1,000, if you're taking away 25%, you're keeping 75%. So that's what I'm going to multiply by. 750 times 0.75 again. So 4 hours later, we have 562.5. Do it again, times 0.75, 421.875. Okay, rather than doing all these calculations by hand, I'm going to pull up GeoGebra, and I have had the spreadsheet in GeoGebra do all these calculations for me. You can see I started with 1,000, 750, 562.5, 421.875. Those are the values we just calculated by hand, but there were a lot of them, so I had the computer do the rest for me. Now I want to plot these points, so I'm going to highlight all of them. Create list of points. I can't see them because I don't have a great window. I'm going to close my spreadsheet at this point so I can see more of my graph. And then let's see, my x values go from 0 to 48, so I want to make sure x shows that. And then my y values start at 1,000 and get smaller, so I need to make my y much larger here. There we go. There's all my points. And I'm just going to hide the labels. Oops. There we go. All right, so you can see this exponential decay curve. Right, this is my exponential decay flavor. So we already graphed the data. Now I want to write an equation of an exponential function that models how much drug remains in the body t hours after the injection. So this is a little tricky because the 0.75 happens every 4 hours. So you can only multiply by 0.75 if a full 4 hours has passed. So we need to take the time that has passed, say 24 hours, and say, all right, how many sets of 4 hours is that? Well, so you do 24 divided by 4 and you get 6. And you say, okay, that means that 6 times I have reduced the amount of drug by 25%. So we would say I named this something already? No, okay. The amount of drug in my system after time t, well, I start with 1,000. I'm multiplying by 0.75 at each time interval, but my time intervals are 4 hours. So I have to take the number of hours that have passed and divide by 4 to see how many times I multiply by 0.75. All right, I want to answer this question 3 ways using the graph and the table and the equation. How many milligrams of blood are in your of the drug are in your blood after 2 days? So 2 days is 48 hours. So I'll start with the formula. I want to do A of 48. So that would be 1,000 times 0.75 to the 48 over 4. So 48 over 4 is 12. So this is 1,000 times 0.75 to the 12. I'll have my calculator do this. 1,000 times 0.75 to the 12th. I get 31.67 milligrams. Let's verify this using our table and graph in GeoGebra. So I'm going to pull back my spreadsheet view. So 48 hours is 12 units of time. Is that right? Okay. So okay, so yeah, I want to find 48 hours, 31.6764. That's what we got. And then if I look at a graph of this, I wrote a formula, so I could graph it. A of t equals 1,000 times 0.75 to the t over 4. But actually, I think GeoGebra requires you to use x as your independent variable. There we go. Try this again. A of x equals 1,000 milligrams multiplied by 0.75 raised to the x over 4. There we go. I must have typed it in wrong. All right, so it goes right through all my data points perfectly. So I want to know after 48 hours, so I would just type in A of 48, or find 48 on my graph, go up, and get the y value is about 30, 31.674. Okay, will you ever completely remove the drug from your system? Well, if you're always taking away 25%, then you're leaving some. So even if you have a very small amount, you're never going to completely get rid of it. No, right? You're always leaving 75% behind. It will get very, very small though. Very, very small. So small that a blood test will be unable to detect the amount, right? So if a blood test is able to detect the presence of the drug, only if there's at least 0.1 milligrams in your blood, how many days will it take for that to happen? So I want to solve 0.1 equals 1,000 times 0.75 to the t over 4. So I'll have GeoGebra do this for me. So I'm going to graph y equals 0.1, very, very small. So I'm going to change my scale a little bit so I can maybe see that. There we go. And it's going to take a long time to get there, so I have to move my x. So this, it looks like between 120 and 140 hours. So let's actually have GeoGebra find where those intersect. Intersect A and F. It says point N is the intersection point, and that is at 120, about 128 hours. So 128 divided by 24 is 5 1/3 days. So this is between 5 and 6 days. All right, next question. The population of India was about 1.25 billion in 2013 with an annual growth rate of about 1.2%. We want to find the growth function that models India's population and let t represent the number of years since 2013. And then find the population of India in 2031. So P of t, the initial amount is 1.25 billion, 1.25 billion, times my growth factor would be change 1.2% to a decimal, 0.12 to the t. And then India's population in 2031, well, how many years since 2013 is that? 2031 minus 2013 is 18 years. So I just have to evaluate P of 18. Have my calculator do it. I do 1.25 billion times 1.012 raised to the 18th. And I get 1.55 approximately billion. The car valued at 38,000 in the year 2007. By 2013, the value had depreciated to 11,000. If the car's value continues to drop by the same percentage, what will it be worth in 2017? All right, so I've got 2 points. I've got like 0, 38,000. And then 2013, that's 6 years later. So I have 6, 11,000. All right, so if I'm looking for a formula, P of t, maybe I'll call it V for value, V of t equals A times B to the t. And A I know is my starting value, so that's 38,000 times B to the t. And then I know another point on the graph is, or on my function is 6, 11. So that's 6 is t for time, 11 is value. So I put 11 equals 38 times b to the 6th. And I have to solve for my growth factor b. All right, so I'm going to do 11 over 38. And I get a decimal, and then I have to take the 6th root of that to get b by itself. So I have b to the 6th is approximately 0.289, and I have to take the 6th root of that to get my b value. So the 6th root I could get by typing 6, and then in my math menu there's an xth root, option 5. So I want the 6th root of the previous answer. That didn't work. 6th root of 11 over 38. And I get 0.813. So my formula is going to be V of t is 38 times 0.813 to the t. I'm just writing on this graph, sorry. It's just the answer key. V of t is 38 times 0.813 to the t. And then my question is, what will this car be worth in 2017? So that's V of 10. That's 10 years after 2007. 38 times 0.813 to the 10. $38 times 0.813 to the 10th is 4.79 thousand. All right, number 8, identify whether the statement represents an exponential function. Explain. The average annual population increase of a pack of wolves is 25. So that's 25 wolves per year. That's linear. They're adding 25 wolves each year. And the population of bacteria decreases by a factor of 18 every 24 hours. That is exponential because the word factor indicates multiplication.